This is the lecture for lesson 29. This section is all about log properties. So we're going to start with basic properties, the product rule, quotient rule, and power rule for logs. So here's the first basic properties. Log of 1 is the property name, and the answer is 0. So log of any base asking for 1, the answer is 0. Next one, log of the same number as the base. So if we have log of base A to the A is going to equal 1. Now that also means the same, similar. So if I have log base A of A to a power here, let's say X, the answer is X. A number raised to a log. So A is raised to the same base log. So log base A of X is just X. So what's happening here, if you ever have a log base A and then the next value you have is A, or vice versa, A, log base A. So those values are the same next to each other. They cancel each other out. They undo each other. So let's use those properties here. Log base 4 of 4 to the 6th. So that's this second property here. So when the base of the log equals the base of the piece right next to it, the answer is just the exponent 6. Next one, e to the natural log 12. Well, that's a number raised to the same base log. So e raised to the log base e cancels each other out. It just leaves me with 12. And the last one, any log of 1 is the answer 0. Now, if you didn't know all that, you could change everything around, whether it's exponential, back to log form, whatever. I could have taken this and said 4 to what power equals 4 to the 6th. And then I see, oh, yeah, that's 6. That makes sense. So e to the natural log 12. So let's see, where e to the natural log 12 equals what? So if I change that, this is exponent form. I want to change it into log form. Base exponent answer. Log base e of x equals natural log 12. This one may be a little bit harder to work through. But c is easier to do. So natural log is the same as log base e of 1. So it's saying e to what power is 1. The only way you get 1 is when you raise it to the 0 power. So this one wasn't, the middle one's not as easy to kind of figure out, but the other two you could have. So the next rule is called the product rule for logs. Basically what that means is if inside of your log you have two things being multiplied together or 3 things being multiplied together, it can be any number of things being multiplied together, we can break them into individual logs being added together. So that is going to be called expanding. So if we go from a single log out to more logs, we are expanding. If we go from multiple logs back to a single log, we're then going to write it as a single log. So depending on what we're looking at, we may have to do either or. So this property, we have log base 8 of 12 times 6. What that means is I can break it into 2 pieces. Log base 8 of 12 plus log base 8 of 6. And know that this property goes both ways. So if I have this first one, I can go to the second one. If I have the second one, I can work back to the first. B, log base 9 of 9x. So that's going to be log base 9 of 9 plus log base 9 of x. Now, this is one of those properties. Log base 9 of 9 is 1. So this is actually 1 plus log base 9 of x. And the last one, log base 4 of x times y, is log base 4 of x plus log base 4 of y. The quotient rule, up next, says that if we are dividing two terms inside of a log, we can separate them as two separate logs with a minus sign between them. So if we have log base 3 of 14 over x, I can break that into log base 3 of 14 minus log base 3 of x. So the numerator is always going to be the positive piece. Whatever's in the denominator is going to have the minus sign in front of it. So minus log base 3 of x. Next one, log of z over y is going to be log of z minus log of y. And the last one, natural log of e over 8 is the natural log of e minus the natural log of 8. And the natural log of e is just 1. So 1 minus the natural log of 8 would be that one. Right, the last rule is the power rule for logs. And basically what it means is if you have a power on the term on the inside, what we can do is we can pull that power out front, and you'll see them put it there. So let me use a different color. They take that power on the inside piece and put it in front of the log. So log of y to the negative 8 means I can take this power negative 8 and bring it to the front and make it negative 8 log y. Log base 2 of the 4th root of 7. So any root is an exponent. So we need to think about this first here. I'll pick a different color. So this is log base 2. A 4th root is a 1/4 power. So I need to know that this is 7 to the 1/4 power. And that 1/4 can now come out front. So 1/4 log base 2 of 7. Now this next one, we need to be careful. The 3rd power is only on the y. There are 2 pieces inside here. So what I need to do is I need to first do the product rule, and I'm going to break this into 2 pieces. Log base 5 of x plus log base 5 of y cubed. So power rule is always kind of like the last thing you're going to do here when you have more than one piece inside. I can't do anything with this first one. It's as it is. But the second one, I can bring that 3rd power down. So 3 log 5 of y. So there are some times you're going to see a combination of them, and we need to work with them combined. Next is some true and false. So let's see, did we do these correctly? Is the natural log of 6x plus the natural log of 1 equal to the natural log of 6x? Well, on that first property slide, we said log of 1 equals 0. So natural log of 1, this piece is 0. And anything plus 0 is the original piece. So yes, this is in fact true. Okay, let's look at the next one. Log base 2 of x y to the 4th over 16. So it looks like the first, so I'm going to, generally for me, I try to work the problem out myself. So I see that this is a quotient rule first. So I'm going to break this into log base 2 of x y to the 4th minus log base 2 of 16. And that is the first line that is correct. Okay, the next thing I see is that this first piece is a product rule. So I need to break that up. So this is a product rule. So log base 2 of x plus log base 2 of y to the 4th minus log base 2 of 16. And that is not what they did here. So we need to keep working on this problem. All right, so let's think through here. Log base 2 of x, can't do anything with that. I can bring this 4 down, so plus 4 log base 2 of y. And then I'm going to rewrite this. 16 is 2 to the 4th power, so log base 2 of 2 to the 4th. And that's how they're getting that 4 on the end there. Log base 2 of 2 those cancel each other out, leaving just 4. So log base 2 of x plus 4 log base 2 of y minus 4 would be the correct answer. Okay, here's how I know this was incorrect here. This fourth power is only on the y. It's not on the x term as well. I cannot bring this fourth power out front because it's not attached to both pieces. So this one was false. So kind of putting it all together, we're going to expand some logarithmic expressions, just like that last true-false, and then we're going to condense them. And lastly, talk about what's called the change of base formula. First up is expanding. We have log base b of x to the third y over z squared. So what I'm going to do first is break up the division. So log base b of x cubed y minus log base b of z squared. Once I have done the quotient rule, then I'm going to do my product rule. So I did quotient, then I'm going to look for product rule, then I'm going to look for powers, and lastly, I'm going to see if I can simplify. So you're always going to want to do it in that order. All right, so this is going to be log base b of x plus log base, x cubed, plus log base b of y minus log base b of z squared. So we did the product rule. Now we're going to bring our powers down. So 3 log base b of x plus log base b of y minus 2 log base b of z. And there's no simplifying here because these are letters. All right, b, I'm going to start with that quotient rule. Log base 6 of root 6 minus log base 6 of 36. Now, there's no product rules left. This is a single piece and a single piece. So now I need to look if there's any powers or to simplify here. Well, square root 6 is 6 to the 1/2 power. And 36 is 6 squared. So I'm going to make that log base 6 of 6 to the 1/2 minus log base 6 of 6 squared. And then the rule is if the log base matches the next piece, the answer is just the exponents. This is 1/2 minus log base 6 of 6 cancels out minus 2. 1/2 minus 2 is -3/2. So that one simplified to an entire answer. All right, C. I'm going to work with that quotient rule first. And actually, I may need to go over here so I have enough room. All right, log base 2 of the 5th root of x, y to the 4th, minus log base 2 of z to the 7th. Okay, I have a product rule now. I've got x's and y's, so I'm going to do those next. Log base 2 of the 5th root of x plus log base 2 of y to the 4th minus log base 2 of z to the 7th. Okay, now I'm going to do the powers. The 5th root of x is x to the 1/5 power. So that is a 1/5 log base 2 of x. The power on here is 4, so plus 4 log base 2 of y. And then the power here comes down minus 7 log base 2 of z. So I hope that's making sense. With a little more practice, it may be even better. So now we're going to go the other way. Now we're going to condense them. Now we have more than one log and we want to rewrite them as a single log. So we're going to kind of work that opposite way first. So now we're going to work powers And then we'll see if there's any products we can put together and any quotients. So looking at the first one, we have log of 250 plus log of 4. So we don't have any powers. So then we're going to look for product rules. So that means pluses. Pluses are going to turn into products. So that's going to turn into log of 250 times 4. Well, 250 times 4 is 1,000. Log of 1,000. Well, common log is a base 10. So let's think about this. Log base 10, 1,000 is 10 with 3 zeros, so 10 to the third power. Well, log base 10 of 10, those cancel each other out, leaving me with just 3. So just like before, you may be able to simplify to a single number. So I'm going to add the last one here, simplify if you can. All right, working with B, we have log of 3x plus 5 minus log of x. So no powers, there's no numbers in front, so can't do that. There's no pluses for products, so now we're going to look for minuses for quotients. So I'm just going to turn this into one big fraction, log of 3x plus 5 all over x. And there is nothing else that I can do with this problem, so it is done. All right. Next one. We have 1/2 times the quantity log of 5x minus log base 5 of y plus 3 log base 5 of x minus 1. So what I need to do first is this 1/2 has to go to both pieces. So 1/2 log base 5 of x minus 1/2 log base 5 of y plus 3 log base 5 of x minus 1. All right, so that 1/2 is going to go, we're going to do those powers. So log base 5 of x to the half minus log base 5 of y to the half plus log base 5 of x minus 1 to the third. So all of those powers are going to go back up, the 1/2, the 1/2, and the 3. Okay, so now we're going to look for our products and our quotient rules. So I'm going to work left to right here. So we have this first one minus the second one. So I'm going to make those two into a fraction. So log base 5 of x to the half over y to the half. And then I have plus log base 5 of x minus 1 cubed. I'm going to do one at a time. Okay, so now I have a plus here, which means I'm then going to take this one and multiply it to that one. So log base 5 of x to the half over y to the half times by x minus 1 cubed. I'm going to put this in a big set of parentheses here. The last thing you may see is these both have the same power of half. Well, a half power is the same as a square root, so I could write this as log base 5 of the square root of x over y times x minus 1 cubed. Key things to note, okay? I could have, at this step, gone right to here, okay? Because they're all log base 5s, so I would have done log base 5. This first one is x to the half, so I know that that's on top. Y to the half is a minus, so that has to go underneath. And then plus means I'm going to multiply on the outside here. And then you could have changed these both 1/2s into a square root. So there are a few other shortcuts. I just didn't want to jumble too much at once, but you can always take multiple pieces and know that all the pluses are going to be on the top or multiplied together, and then the minuses are going to be on the bottoms. The last thing in this section is called the change of base formula. Here's where it wants us to, it's not a nice answer. Okay, we can't just turn a log into an exponent and get a nice answer. So we want to know what is the answer to log base 7 of 320, this first one here. Well, our calculators only have the natural log, which is a log base e, and common log, which is a log base 10. Our calculators don't have a way to type in log of another base. I can't type log base 7. So what we can do is use what's called the change of base formula. And we have two numbers. So the way I always see this as the smaller font and the larger font. And the larger fonted number is the one that's going to go on top. The smaller fonted number is the one that's going on bottom. And it doesn't matter if you use the log button or the natural log button. We can take any log here of any bases and calculate it in a calculator. So this is asking me to take the log, the larger font is 320 over the log of 7. So in your calculator, you'll do log of 320, hit enter, get that answer, and then take that divided by log of 7. You should come up with 2.9643. I'm going to show you a slide on Desmos here in just a second. And then same for this next one here. So this larger font is 27. The smaller font is 9. And this one will give you 1.5. Now I'm going to show you both with log and natural log, and you'll see that they both get you the same answer. All right, so here I am again in Desmos, and you can literally just type LOG in your keyboard, and what it does is it changes any normal letters. It's going to keep it italicized until you type in the function log. It then makes it non-italicized, so it's telling you, hey, I found the function. So log of 320 divided by log of 7, and then I also showed you could have typed natural log. They both give you the same answer here, so it doesn't matter which one you're using, log or natural log. Just make sure you use the same one for both parts. And then the same for the second here. Again, you always take the larger written font number over the smaller font number. So the base is always the one on the bottom, and then you'll get your answer here. Pretty straightforward. You just use your keyboard to type log or natural log, your number, hit the divide button, and type your denominator 1 in as well. All right, that's the end of this section. You can go ahead and do your homework.